All right, let's finish up this chapter with the last few problems that are on your assignment. Um, we finished, the last one was number 29, so let's move to number 30. Number 30 states, what magnitude of point charge creates a 10,000 Newton per coulomb electric field at a distance of 0.25 meters? How large is the field at 10 meters? Okay, so you have E equals K Q over R squared. And now you want to solve this for Q, because that's what you want to know. So that's going to be E over K times R squared. And so that's going to be, it was 10,000 coulombs per, or 10,000 newtons per coulomb divided by 8.99 times 10 to the ninth times 0.25 squared. And so that's going to equal 6.95 times 10 to the minus 8 newtons, or excuse me, coulombs. That's the charge. Now, it asks what would this be at same situation, but what would the field be at 10 meters? You just put in the new number for the distance. So it's 10 squared, and then the charge is 6.95 times 10 to the minus 8, and that's going to equal 6.25 newtons per coulomb. Find the direction and magnitude of an electric field that exerts a force of 4.8 times 10 to the minus 17 westward on an electron. Okay, so first of all, this is 32, A. So E is equal F over Q. That's a formula that's in your book. And if you put the force, which is 4.80 times 10 to the minus 17, and the charge of an electron is 1.6 times 10 to the minus 19, then the charge has to be 300 newtons per coulomb eastward, opposite direction. Because the charge here is going to be negative, this will be negative, and so that makes it the opposite direction if the force is positive. If you say westward was negative, then it would be east, because then the positive would be eastward. Okay, B. The second part is, what is the magnitude and direction of force does this field exert on a proton? Well, it's going to exert the same force because the charge on a proton is the same as the charge on an electron. But it's going to be in the opposite direction because electrons are positive, and so this will be, the force will be east. 33. Now, 33 and 35 are just drawing pictures. And there's a certain convention for drawing pictures that I'll point out here. So 33 is sketch the electric field lines near a point charge of 1 plus. Does the point do the same for a charge of 3 times that? Well, the basic point here is that if you have Q, then by convention you have a single arrow that goes in each of 4 directions, because that's Q, okay? So that 3Q means that you'll have 3 times as many arrows. So you have 1, 2, 3, 4. So you have that, but then you also have 2 more for each extra charge. So it looks something like this. Not a very good drawer here. And so 3Q is only different from Q in that it has 3 times as many lines as Q does. And 35 looks at the same thing. If you look at the diagram in 35, if you count the lines around the smaller positive dot, the one that has the most lines, you'll see that there are 23. If you count the lines that come out of the other one, you'll see that there are 11. And so the ratio of the two charges is 23 over 11. Now, because they're in opposite directions, this would be a positive, and this would be a negative, and this would be a negative. But the ratio is 1.9 positives to every 1 negative. Then it says in B, it says, sketch the electric field lines a long distance from the charges shown in the figure. Well, you wouldn't, basically the first thing you would do is say that the 23, you would subtract 11 from that, because what would be left would be the unpaired, at a long distance would be the unpaired. Again, if you look at the picture, you can see that all of the 11 that come out of the one on the right are paired. So what's left is the ones that are not, that are kind of going off like hairs. And so you end up with 12 unpaired, and they are a positive 12. And so, which means the arrow points outward. And so if you were to draw it at a distance, it would be a dot with, again, 12 arrows, very much like this. It would look very much like that. Number 41, and this is the last one actually. And number 41 is interesting. It's the kind of problem I find interesting, so you should make sure you understand how to do this. It says, what is the force on a charge located at x equals 8 centimeters, given that Q is 1 microcoulomb? Okay, so we have to basically draw this line, and I tried to draw it at scale here. So you have 0 is over here, and 15 is right here. And so 10 is right about there, and 5 is right about there. So this is 10, and this is 5. And what they show here with A is at 3 centimeters, there's a charge of plus 1 coulomb. At 8, there's a charge of minus 2 coulombs. And at 11, there's a charge of plus 1. So the question is, what is the force on this charge right here, given this setup? Okay, so this one's at 11, this one's at 3, and so you want to know the impact. You can see that you're going to have an attractive force in this direction, an attractive force in this direction. And there's some things you can deduce out of this. First of all, they're against each other. Okay, they're in opposite directions. Okay, so basically the net force, the force net, is going to equal, and this one, 8 to 11, is closer than 8 to 3. Okay, so I'm going to say the force generated by the one at 11, 8, 11, minus the force generated by the 3 to 8. That way you'll get a plus number. And when you get the plus number, that means that it's to the right. Now once you figure this out, then all you have to do is calculate the force. And it's not as hard as it sounds, okay? What you end up with is the F net is equal to the K Q. Okay, so this is the 8, 11, okay? So this is going to be this guy and this guy. So it's going to be the 8 and the 11. So it's going to be the 8 times the Q at 11. And that's going to be divided by this distance, which is 8 minus from 11 is 3. or 3 centimeters, or 0.03 meters squared. And so that's going to be subtracted, K times, again, the Q8, but now it's going to be the Q at 3, and then the distance is going to be 0.05 squared. So what you end up with is 8.99, which is K, to the 9th, excuse me, times, and these two are going to be, so Q is 1 times 10 to the minus 6 times minus 2 times 10 to the minus 6 over 0.03 squared minus 1 times 10 to the minus 6 times a minus 2 times 10 to the minus 6. Now, because I put the minus signs in here, this actually should be plus now, because I put the minus signs in. If I wanted to do it the other way, I would have left the minus signs out. So that's divided by 0.05 squared. And then you end up with, if you do the math here, you end up with basically 2.22 times 10 to the minus 9 minus 8 times 10 to the minus 8, no, 10, excuse me, times 10 to the minus 10, and that quantity multiplied by K, 8.99 times 10 to the 9th. And when you do that multiplication, you get 12.8 newtons to the right.